So we've got three shapes. We've got that one, which would be a y is proportional to x squared. So that's a unique one of a kind. There's no other possible relationships that could fit that equation. Then you've got your square root shape. That is that y is proportional to the square root of x. And then the final one, which we'll just give a little bit more space to. In fact, we'll just shrink it down. It's much more fun. I love doing that, but
it's cool.
Anyway, your final shape is your inverse, and it's one of three inverse relationships. So it could be y is proportional to 1 over x. It could be y is proportional to 1 over x squared. And it could be y is proportional to 1 over square root of x. Could actually be any one of a number of other inverse equations, but these are the ones that we'll select from. And how you decide which of those is based on the equation that they give you. So you might have, at the bottom of your working out sheet, you might have, say, F equals ma. And your investigation is into mass and acceleration, how much mass is required to accelerate something, whatever. But from that equation, if you know that, say, the force is constant, you can whatever the constant value is, you almost ignore that and you rearrange to put the other two variables on each side of the equation. So in this case, we'd rearrange to either put mass over here or achieve, so it'd be A equals F over M. Oh, that's cool when it does that, but anyway, F over M, or it could be M equals F over A, but either way that's clearly an inverse, not an inverse square, not an inverse square root. If you had, what's an inverse square situation? The equation for light intensity dips off at a square relationship. It would look something like this. The intensity of light equals some constant times the 1 over d squared. And that one's a little bit more straightforward because you wouldn't have to do any rearranging. I don't know what that k value is. Sometimes it's made up of a whole number of confusing things. Yeah, and then that last one's pretty unlikely, but it'll just be a really complex equation. There's one other way you can tell actually, which helps. I've just got a different colour to do this one. Is that sometimes on that curve you might just get a kind of a shallowish curve. That's more likely to be that one. If it's a steep curve like that one, it's more likely to be that one. So that's, yeah, and that one's just hard. Look for a really crazy equation, and yeah. But if all else fails, even if those two steps of finding which it is fail, just plug numbers in and try them out, and if you get a straight line graph or a transform graph, then that's likely to be the one. And if you get a straight line graph or a transform graph, that's fine anyway. Is that cool?
Yeah.
No questions?
And even with, not to do with this, I understand that now.
Okay.